The immutable laws of physics will transform Moore's law into Moore's wall. Voltage scaling has already plateaued. Feature scaling will grind to a halt when transistor size shrinks to about 30 atoms of silicon. The current paradigm of computational scaling may be nearly maxed out, but real-world problems requiring monster compute capacity expand and multiply. Making components smaller and smaller in order to make machines faster and faster has reached the top level in the development of high-performance computers. What's next? For ASC, it's aligning with the Department of Energy's Exascale initiative. Exascale isn't about just expanding current technology. It's a game changer with unprecedented technical challenges related to power consumption, networking, and system architecture. And that's just the hardware aspect. Exascale also means completely revamping scientific application codes to run in an environment that dwarfs the current massively parallel systems of hundreds of thousands of processors with hundreds of millions of processors. ASC is engaging in this profound challenge because by 2025, it must provide the predictive simulation capabilities to understand an aging U.S. stockpile.
Since the dawn of the nuclear age, NNSA and its predecessor organizations has always had the mission of a safe, secure, and reliable U.S. stockpile. We've always talked about it in those terms as a nuclear weapons complex. But as we realized that the tools and all that we built actually have broader national security implications, it could be used for a non-proliferation and counterterrorism kind of activities, and in a broader context for making national security decisions.
In the future, computational needs for nuclear counterterrorism are potentially greater than those needed for stockpile stewardship. For instance, in the event of a nuclear detonation by a terrorist organization, a rapidly generated, highly accurate profile of the type of device detonated could help identify the perpetrators. While nuclear stockpile stewardship and national security are the main drivers for ASC's Exascale development efforts, advanced simulation capabilities will spin off solutions to other critical scientific challenges, such as climate science, combustion, genomics, molecular and even atomistic modeling, and nanotechnology. Extraordinarily complex problems like these are difficult to model with a high degree of fidelity because the effect of the tiniest uncertainties in input variables can ripple through a simulation with significant impact on output results. And that's what makes Exascale such a game changer. When fully deployed, it will have the potential of providing the compute power necessary to quantify uncertainties, thus ensuring greater confidence in simulation accuracy. Aggressive development of Exascale will challenge the brightest minds to reimagine computing in a whole new development ecosystem. Instead of the current parallel computing environment with components adapted from the PC industry, the new development ecosystem will deploy components from industries like mobile devices, and particularly gaming, because they share the same requirements for powerful components that consume little electricity. Exascale, it's a whole new game. ASC aims to be a leader.